We are the Group 3, and today we will present our topic on dynamic programming and how it applies to solving real-world problems. In this slide, it is all about dynamic programming. Dynamic programming, or DP, is a method used to solve complex problems by breaking them into smaller subproblems. So it was introduced by Richard Bellman in 1950s, and it's commonly used for optimization and search problem. So it is closely related to divide and conquer approach if you're familiar with that, but dynamic programming works bottom up and solving smaller problems first to build a final solution. There are two main approaches in dynamic programming, which are backward recursive and forward recursive. Backward recursive starts solving from the final stage to initial stage, optimizing decisions step by step. Meanwhile, forward recursions build the solution progressively from the initial stage to final stage, but both this method is useful in different scenarios. So let's apply dynamic programming to a real-world scenario. So this is our case study in problem. Luella, a resident of Balagtiki, Dumanhog, is an adventurous student traveler who wants to visit Tasmania Peak, a famous hiking destination in Mantalongan, Balagit, Cebu, with her family. However, she can take 7 different routes to reach her destination. Luella wants to find the shortest path to minimize travel time and energy while enjoying the scenic journey. Here are the different routes Luella can take. Each route has varying distances in location, so our goal is to determine which route is the shortest and most efficient using dynamic programming techniques. Using backward recursive method, we plot the diagram based on the different routes stated in the slide and include their corresponding distances. So we separate the routes into stages to systematically track the shortest path by comparing the available routes. So there are 9 stages as we can see. And since we are using backward recursive method, we start from the final stage and work our way back to initial stage. So first, we determine the functions for each node to identify the shortest path. So the function of p here is 0. Why? Because there are no further decisions to be made beyond this stage. Next, we evaluate O to P, which requires traveling 16 kilometers. Therefore, we conclude that the value of function O is 16. We then apply the same process to the other nodes, selecting the optimal distances at each step. So the value of functions is already complete. So we can substitute now the functions value for each route. Since there are 7 routes, so each route we must sum up the functions value to determine the optimal value. As you can see, these 7 routes are already solved in the slide, so the shortest path will be the optimal path that Luella should choose, which is route 5, which is A to C, C to D, D to H, H to K, K to P, and their values are 49 plus 41.2 plus 37.6 plus 33.3 plus 26 with a total of 187.1, and the location that Luella should choose is Tumanhog to Runda, Runda to Alcantara, Alcantara to Moalboal, Moalboal to Badyan Bugas, Badyan Bugas to Mantalongon, which is Usmeña Peak, our goal still, using this backward recursive method.
Everyone, I am Sherwin T. Caoba, and now I am discussing how to solve this problem using the solution of the forward recursive method. So this is our tabular in solving forward recursive methods. Start at the initial stage, which is our A, the stage 1, and work forward toward the final stage, which is our P, the stage 9. So the table introduces this step-by-step process where each row represents a transition from one location to another with a corresponding distance. At stage 1, the journey begins at location A, which has 2 possible paths, A to B 13 kilometers and A to C 7.80 kilometers. Since A to C has a shorter distance, it becomes a preferred path for further calculation. Moving forward to stage 2, location C has 2 possible paths, C to D 3.60 kilometers and C to E 40 kilometers, the shorter route is C to D, leading to a total distance of 11.40 kilometers. Meanwhile, at the same stage, B to F 21 kilometers results a total distance of 34 kilometers, which is significantly longer than the path through C. At stage 3, location D has direct path to H for 30 kilometers, resulting in a total distance of 15.70 kilometers when added to previous stage. Similarly, other locations such as F to J 7 kilometers and E to J 17 kilometers continue their own respective calculations. Through these paths are ultimately longer. At stage 4, the shortest path continues from H, which has two possible options: H to I 16 kilometers and H to K 7.30 kilometers. Choosing H to K results in a total distance of 23 kilometers, which is optimal compared to H to I at 31.70 kilometers. As the process continues to stage 5, the shortest path selections remain consistent, with K to P 26 kilometers at stage 6, leading to a total minimum distance of 49 kilometers. Other locations such as I, J, K, L, M, and N have longer alternative paths. The method concludes at stage 8, where the final step, O to P 16 kilometers, results in a total distance of 96 kilometers. So, the A to C, C to D, D to H, H to K, K to P route is the optimal solution, or the shortest path with a total distance of 49 kilometers. The results and finding using two recursive methods that they have the same route but different distances. Therefore, Luella should choose Route 5, Dumanhog to Ronda, Ronda to Alcantara, Alcantara to Mualbual, and Mualbual to Bugas-Badian, and Bugas-Badian to Mantalongon as the shortest pathway from Dumanhog to Osmeña Peak in Mantalongon, with a total distance of 1.87.10 kilometers using backward recursive method and 49 kilometers using forward recursive method. The distance that we use in our problem are based on real life distance from these Google Maps that shows. In conclusion, this case study highlights the effectiveness of backward recursive method and the forward recursive method in dynamic programming to solve real-world route optimization problems. By applying these methods to Luella's journey to Osmeña Peak, the study identifies Route 5 as the shortest pathway. The optimized route passes through K towns including Dumanhog, Ronda, Alcantara, Mualbual, Badian, Bugas, and Mantalongon. This solution effectively minimizes travel time and energy, allowing to Luella enjoy her scenic trip while ensuring she reaches her destination efficiently. By systematically evaluating each stage, the most optimal solution is identified, ensuring Luella can choose the shortest and most efficient path to Osmeña Peak. That would be all, and thank you for listening.